Alright, so this is Chapter 2, Trigonometry, for Precal 10. Making sure you guys are in the right video. This is kind of going to be what it's going to be like for the next couple of days. So, when it comes to trigonometry, there's basically three main ratios we're going to figure out and learn how to use. Trigonometry is extremely useful, especially when you guys are going into Precal 11. It's kind of a big unit there. So, trigonometry is all based off of right triangles for grade 10. So if you think back to probably close to grade 6 and grade 7, there were three types of triangles you were supposed to remember, or at least learn about. One was the right triangle, and basically any triangle that had a 90 degree in it, and we show that with a square in the corner. And that will basically show us or tell us exactly it is a 90 degree or right triangle. You would have learned about an isosceles triangle, which is basically a triangle where two of your sides are equal in length and two of the sides, or one of the sides, is not. We always show that they're the exact same with a line. And if you cut these in half, you basically get two 90s. It's a good trick for later on. Your last triangle would have been an equilateral triangle. And basically all three sides are going to be the exact same. And again, you show that by three lines. And each of these angles would be the exact same. Okay. Things to also remember would be the different types of angles you had. You should have known about an acute angle, basically an angle that is less than 90 degrees. You should learn about an obtuse angle. Obtuse is greater than 90, but it is less than 180. There is a reflex, or rather a reflex angle, so anything that is over 180 degrees. So this would be a reflex. We just told you guys about the right angle. Basically exactly 90 degrees. And there's technically 180, but that's not really an angle. Two of the more important terms we care about are the angle of inclination and angle of declination. Basically, if you have a line on a horizontal, almost think like a lazy boy chair. If you recline back, you incline. And so this here, if your angle is going up from the horizon, this would be an angle of inclination. If you had an exact same horizontal line and your angle went down from the horizontal, that would be an angle of declination. It's not very useful right now, but later on when you guys start taking the word problems, we'd like to use these a lot to give you guys better understanding of what's happening. Now we're starting to get into actually the main portion of trig. Again, this has all been reviewed so far. This should be kind of new. There are three labels when it comes to trigonometry for each of our three sides. Hypotenuse, opposite, and adjacent. Each of these has a meaning, and the meaning is kind of important. So your hypotenuse is always going to be your longest side. No matter what happens, and no matter what you're dealing with, it will always be the longest side. So out of these three sides, this is our hypotenuse. Another trick to remember is the hypotenuse is always going to be the opposite from the right angle. Your adjacent will always lie between your opposite and hypotenuse. The opposite side is always the opposite side from your main angle, basically the angle at which you're going to label your triangle from. If we're looking at this bottom angle down here, the opposite side would be this guy, which would leave this as our adjacent. It's important to note that if I wanted to label this triangle from up top, The hypotenuse wouldn't change, but your opposite and adjacent, they would flip on you. Way back in grade 9, when we were to label your angles using letters, we always had large C was your angle, little c would have been your longest side, and then A and B doesn't really matter, except your capitals were always your angles, and your lowercase were always the side lengths. So that was kind of all refresher and a bit of review. Now we're kind of getting into the newer stuff. There's an acronym we guys teach you, which is called SOHCAHTOA, and it's basically to help you remember the 3 trigonomic ratios. These are the only ratios we care about in grade 10, and when you hit grade 11, there's going to be a couple more, but they stop dealing with right triangles, and it makes it a bit more tricky. There's also one thing I want to point out right now, that if you look at your calculator, this is where it matters the most, what setting your calculator is set to. If it is set to radians or gradians, it will not give you the correct answer. You always want to make sure it's set to degrees, because when I use my sine, cos, or tan functions, if I have it in a different setting, it uses different ratios. It doesn't quite work out the same. So if you have your calculator set to radians and you do your entire test in radians, it is going to give you almost every single wrong answer, and it will make your life kind of miserable for that test. So always make sure it's set to degrees. Usually before a test, I'll try my best to say, hey everyone, punch in, and I'll give you a number. And if you don't get the correct answer, we fix your calculator. So, for right now, we're going to look at the tangent, or TOA, of our trig ratios. Tomorrow's lesson and the day after, we're actually going to look at sine and then cos. So, the TOA stands for basically our tan, opposite, and adjacent. What we care about is tan theta, we don't want to forget our theta, is equal to the side opposite divided by our side adjacent. If we want to shorthand this and reduce it down, we always say tan theta equals your opposite divided by the adjacent. And actually that's usually what your formulas are going to say, or be on the whiteboard, or if you're given a formula sheet. For right now, we're just going to go through this step by step by step and give you guys kind of everything you need to slowly do these. Once you figured out how to solve one trig ratio, the other two, you follow the exact same steps. Whenever you get a question, you're always going to label it first, pick the different ratio you want to find. So looking back at SOHCAHTOA, let's say I wanted to find the hypotenuse and I had the adjacent, I would use cos, and if I had the opposite trying to find the hypotenuse, I'd use sine. In our cases here, I'm going to give you either opposite or adjacent and ask you to find the opposite or the adjacent. So we're going to use the tan ratios for all of these. But you're always going to label your triangle, pick your right ratio, fill in your formula, and solve. It's really important to go through this step by step, kind of slowly, sometimes talking it out as you go. So for this situation here, we're going to label our triangle. Now, we could use 36 degrees. We could use this angle down here, because if you remember, all angles in a triangle equal 180 degrees. If I know this is 90 and this is 36, I can go 180 minus 90 minus 36, and I know that this is technically 54 degrees. That can be useful, but just as a safe practice, it's better to use the one given to you, because you know that no matter what happens, even if you have a bad day, that's going to be correct. If I mess up and say 180 minus 90 minus 36, oh, that's 44, and I do the rest of the question, I get the wrong answer even though I did the math correctly. But you can, if needed, find the missing angle. So when I label this, I'm going to label this based off of the angle 36. So my longest side will still be down here at the bottom, whether or not I flip my triangle or not. From 36, the opposite of 36 is the 5 meters, and my last one is the adjacent, which is up here. So I've labeled my triangle. I'm going to pick the right ratio. I have an angle, I know the opposite, I'm trying to find my adjacent. I don't know what that is. So I look at my 3 trig ratios, in this case, TOA, opposite, and adjacent, that's the right one to use. I then fill out and pick out the formula. So I'm going to go tan theta equals the opposite divided by the adjacent. Always good practice to write out your formula first, then fill it in. So tan of my theta. Theta is Greek for angle, and we're using angle of 36. So we're going to go tan of 36 equals the opposite side, which is 5. This is divided by the, shoot, someone's at the door. Sorry, tan 36 equals 5, which is our opposite, divided by the adjacent, which we don't know. At this point in time, we're just going to rearrange this formula to get our unknown by itself. So I'm going to times both sides by my question mark. These are going to cancel out. I'm now left with my unknown times tan of 36. You can leave it as tan of 36, or you can plug it into your calculator to get a value. In our case, tan of 36 is 0.7265. I'm going to leave it tan of 36 rather than that large number, just so I don't lose any decimals. Again, I'm trying to get my unknown by itself. So if I divide both sides by tan of 36, these two will cancel out. I'm now left with my unknown equals 5 divided by tan of 36. And again, in a calculator, I can go 5 divided by tan of 36, which means my opposite side, or sorry, my adjacent side is 6.88, in our case, meters. The biggest trick is going to be for people to rearrange. And later on there is a shortcut where if your unknown is on the bottom, you can actually just swap the two. Kind of like we did up here, but don't get ahead of yourselves yet. For the second equation, we're going to do the exact same way, except this time you'll notice that we know now the adjacent and not the opposite. We are going to start the exact same way, so you always label it first. Again, I'm going to label it based off of 36. So, this is our longest side down here, the hypotenuse. Our unknown is the opposite, because this is the opposite of 36. And 13, our last one, is now the adjacent. I'm going to pick a trig formula. I still know I'm going to use tan, just because I know the adjacent, trying to find the opposite. So again, tan theta equals opposite divided by adjacent. And I now fill it in. Tan theta, but my theta is 36, equals the opposite, which we do not know, divided by the adjacent, which is 13. Now again, trying to get our unknown by itself. In this case here, a little bit easier if I times both sides by 13. I'm left with 13 times tan of 36 equals my unknown. In my calculator, if I go 13 times bracket tan of 36, closing the brackets, I'm left with an opposite length of 9.44 meters is my unknown. So this would technically be 9.44. That's the very basic and first lesson of trig. So, from when I post this video, you guys are going to have 48 hours to answer just the two questions. Question 1 is you now have to label this triangle using opposite, hypotenuse, and adjacent. I just want it labeled. And question 2 is you're going to have to solve this triangle and solve for length x. So again, remember to fill in or label your triangle. Make sure you're picking the right formula. Good hint, it's going to be tan. And then filling it in and solving. For those of you that are worried about next year and would like more work, again, this isn't required, but it is helpful. If you look on page 75 of the textbook, questions 3 to 8. Again, if you have any questions, I will be online on Tuesday and Thursday to help you guys out. Good luck.